Hello, good evening, and welcome to another session with me, Varun at OdinSchool. And in this session, we would be looking at machine learning with Python. And the topics would be to understand a basic about different variants of classification models. To begin with, we would be having logistic regression, followed by decision tree, and followed by random forest. And by now, I hope you all have an understanding about why do we have to learn machine learning and how is it important. And this topic or this, right, I think this keyword needs no introduction, that is machine learning. Machine learning happens to be a branch or a sub of AI, wherein AI is artificial intelligence. And through AI, we would be trying to achieve greater good, at least technically. And by machine learning, we are trying to ensure that machines are probably learning by themselves, wherein the process of self-learning slowly kicks in, and this self-learning would not require code to be given explicitly each and every time. Now, that's the beauty of it. And this is the reason why machine learning is slowly but surely coming up and steady in the market. And it's already considered to be the hot cake of 21st century. So anyone who is thinking of data science or who's thinking of artificial intelligence or probably deep networking or computer vision, I think should start their journey from understanding what machine learning is. And guys, we here at OdinSchool, we are a technology upskilling platform, and we would help you continuously acquire new skills. Thereby, you could stay skilled and stay ahead. And my name is Varun, and I have an experience of 7 years wherein I've been working as a developer full time and a trainer part time. And over these years, I've been able to touch base on languages like HTML, CSS, JavaScript, R, Python, etc. And also technologies like machine learning, deep learning, artificial intelligence, though at a very basic and a mediocre level. But yes, I've been able to touch upon all these thanks to the different organizations that I've been working or that I've been associated with. So now, the agenda of this session would be to understand what are classifiers. Okay, now just to give it a small understanding, we all know that machine learning is broadly divided into two parts, which is supervised and unsupervised. Now, again, when we talk about supervised and unsupervised, within supervised, we have two methods, wherein the first one is regression and the second one is classification. Correct? So these are the two broad streams that we have within supervised learning. Now, when we talk about regression, here we have different variants of regression, which we've already covered in the session. In the session which we have named as probably Introduction to Linear Regression, if I'm not wrong. That is probably one or two videos behind this. And I think if you've not seen that video, you should check it out, wherein we've been talking about what is linear regression and the types of linear regression. So when we talk about regression, you have two topics, wherein the first one is linear and the second one is multiple linear, which are the most basic variant, but we also have complex variants like polynomial linear regression and etc. We'll focus more on the classification part for now. Now, when we talk about classification, again, classification is a stream of supervised machine learning, right? So within classification, we have a lot of variants. We have typically a lot of variants, wherein we could start with logistic regression, followed by decision trees, followed by random forest, followed by KNN, followed by naive Bayes. We also have SVM, and we have other neural network methods. But then, guys, almost all of these initial topics, they fall primarily into machine learning, and we also, wouldn't hesitate calling them basics of machine learning. Right now, the most important thing here, which is to be understood, is there are almost 80% of these which can work or which act as regression models too. right? But we would still prefer them using or getting used for classification, because that is the roots on which they were built upon. So the agenda of this session, in broad or in a simple statement, would be to understand what is logistic regression, which is the first variant of classifier. Right. What is logistic regression, which is the first variant of classifier, followed by what is a decision tree, which is the second, followed by what is a random forest, which is the third. Right. So I hope you have understood the agenda of the session. I hope you have now a good understanding about what is it that we will be talking about in this session. And this session would be moreover inclined towards understanding the technical aspects of it and understanding the pros and cons, understanding the advantages or the disadvantages. Now, there is another point that I would want to lay stress upon before we go or before we deep dive into each of these topics. Now, whenever we are learning about probably machine learning, or I would say rather any concept in to be generic, we would be starting with what it is, followed by why. Now, when we say what, it is like what facilitated the need for this kind of a classification model, right? Now, just to understand, we had now if the first question was what if we did not have numbers, like what if we did not have continuous variables, and if we had zeros and ones. This led to the discovery of logistic regression. Now, again, within logistic regression, what if it is not just zeros and ones, and what if it is 0, 1, 2, 3? Now, this led to something which is more complex, or which is one step further to logistic regression. Then we had another question, that is, what if it is, a mix of both, or what if it is numbers, and we still might want to classify them? Then we had decision trees. And then we had another problem, that is decision trees can get unstable when the data set is very huge. When the data set is humongous, we know that a decision tree may yield improper results, which facilitated or which forced the requirement of a more robust classifier, and then random forest came into picture. So when we talk about what, you should have a firm understanding about what that topic is, followed by why do we need it. Then the next thing that you would have in succession would be to understand not how and all, would be the advantages, the disadvantages, followed by the case studies, just to understand where and how they are being used, followed by, well, you could still use or try to see what are the different tests that we use to, or I wouldn't mind calling them as evaluation matrix in more technical parlance, right? Then after this, you could still, like, I mean, if you feel that the need of understanding this model is still required, you could then delve into one of the most important thing, that is what kind of data set, what kind of data set would you use on which model, right? This actually becomes the most important part of any data scientist or any machine learning engineer, or probably any data analyst. Data analyst, I don't think, would be working at a very high level of machine learning series. So that is the reason why there is a notion that data analysts stick more over to data exploration or data visualization and data manipulation. But guys, that's not true in all of the cases. So yeah, this is the procedure or the hierarchy that at least I follow when I would want to learn or understand about a topic. Now, this would also include wondering or wandering into other basic associated topics like the math behind it. Now, it is not required for you math behind the formula. Now, here when we talk about the math behind the formula, you would not actually have to require to have a whole derivation level understanding. But if you know or if you have an idea about how the output is getting squeezed out too, it would be really great, because you'll be able to justify and you'll be able to answer yourself as to which model suits where and why, right? And followed by the stats that's involved in coming up with an understanding about the test or evaluation metrics. Notwithstanding this, if you have an idea of all these with regards to almost each and every model, then when one model fails, you know why that model has failed, or probably which other model or what is the next best alternate that you could try upon. So these are some advantages when you understand a topic from the foundation level, right? So now let us go a bit forward and now deep dive into each of the topics. And to begin with, we would take a look at what logistic regression is. Now, when we talk about logistic regression, guys, it mostly works on the concept of 0 and 1. When we talk about logistic regression, here we have zeros and ones, right? Now, there is a very big question, that is, why do we have this name, that is logistic regression, and how logistic regression actually works as a classifier, and what are the advantages and disadvantages associated with a logistic regression, things like that. Now, when we, just to give you a basic introduction, logistic regression is, or logistic regression works moreover on the principle of linear regression. Now that is one of the biggest reasons why we see that logistic, the function, is taken from logit function. Now this is something that we would talk about as we keep going further, but not to worry as of now. Now, when we talk about how logistic regression, we all know how linear regression works, correct? Now, just to have an understanding, if this is a graph and these are the different data points that we have arranged. Now, we know that when you want to understand if it is linearly distributed, or if you want to come up with a line of best fit, then again, here, please do not take the data to be so typically arranged. Now, this would be the line of best fit, wherein here we have a lot of things like residuals, which would be considered. We have residuals which would be considered between the data point and the line of best fit. And based on all of these, we would have something called as the square of errors is considered, and based on this we come up with something called as RMSE. RMSE stands for root mean squared error. Now when we talk about what is a root mean squared error, this is mostly called as an evaluation metric as far as linear regression is concerned. But now that we are working on logistic regression, this diagram becomes very important, while the rest all is almost baseless. So let us just remove all this which is not required, and let us focus on the most important part now, that is the understanding of logistic regression, or how is logistic regression derived from linear regression. But even before that, just to give you some very basic examples about logistic regression, we have examples like if it is a spam mail or not. Now let me just lay stress upon a couple of real-time examples which we use, or real-time case studies rather. Example would be a very unjustified word. So here I would want to see if the email is a spam or not spam. Now how would your system know this? Behind or behind the screen, now let's talk a bit about the BTS. Now behind the screen you have a set of keywords like sale or offer or discount, or in Indian words like dhamaka or season. Now, these kind of words which represent marketing, they are highlighted, or probably they are much in advance taken into account, and they are used, or they are kept on the stands. And whenever these kind of words are detected above a limit, that is when this email is classified as a spam. So your system automatically decides that because there are a lot of words like sale and offer and discount, this mail is a spam. That is why when you go into your spam, you would mostly have mails from your banks with offers, or probably from some stores with some discounts, or probably with Instagram advertisements. So mostly all of these mails, you would find them in your spam. So this is how this is one classical example. So here spam is 0 and non-spam is 1. Considering this as an example, the second one that we could understand, or the second example that we could choose is this. I mean, this example is a pretty sad one. It's malignant or benign. This is used for cancer patients, okay, to see if the person has malignant tumor or benign tumor. Benign or malignant, now this is 0 and this is 1 here again. And if the person has 0, then it's malignant, which is a very dangerous form. And if it is benign, then it is treatable, right? So these are the two cases. Then this is also used very highly in banking parlance to see if the customer is a fraud customer, a fraudulent customer, or if it is a genuine customer. So these are the different areas, or these are the different places where logistic regression is very frequently used, right, guys? Now, just to understand how logistic regression works on a graphical front, or probably on a data visualization level, instead of, okay, let us assume that there is a small box here, and now within this I have some random set of points. So these are the first set of points, and then here I have my second set. Now what logistic regression, okay, please ignore the last dots, they went a bit coarse. Okay, now these are the second set of points. Now here, when we see that the decision bound, now when we see that the data points are arranged this way, we can, very easily say that you have 0 and 1, right? So all this, but then this here, we cannot come up with a line which is as linear, like in a linear regression, because that's not the agenda. Here we are not trying to find out the relationship between two variables. We are trying to classify. We want both of them separated, right? Now, if you want both of them separated, then you would have to come up with a decision boundary. Now, decision boundary is something, okay, let me just draw one so that we have an understanding. Let me use a white line. Now, this decision boundary looks something like this. Well, this is a very horrible form of a decision boundary. It's definitely not like that, guys. Well, it looks, yeah. Yes, this is how a decision boundary looks. It, to be some to draw it on a very generic parlance, it looks like an S, and it is also called as a sigmoid curve, right? It is called as a sigmoid curve, and this has a mathematical backing into a sigmoid function, right? And this sigmoid function is basically to return a probabilistic value, right, guys? It is to return a probabilistic value. Now, why do we need a probabilistic value? Because here we are coming up with a probability. Right now, let us assume that I have 0 and 1 and I have this. We still see that there are some yellow lines within pink, which means that there is something called as misclassification as well that happens. And misclassification means that the probability can be wrong, or that the estimation can be wrong. right? So this is a basic understanding or the subsurface understanding of logistic regression, right, guys? Now let us just go further into the next part. Right, so here we are, the advantages and disadvantages. Now let's talk about it. Now, whenever we are working on logistic regression, the best part is, right, the best part is it is easy to train, right? It makes no assumptions about the distribution of classes. Now that is this is actually a problem which we face when we are working on linear regression, which is solved here. Then you have good accuracy. Logistic regression generally comes up with a very decent accuracy. Then it is resistant to overfitting. Now what is overfitting? It is the way how we split your training and testing based on which how heavy, or based on how turbulent are you making your data, or how much of algorithm is it taking which is within its capacity or not. It's something like that. When we talk about overfitting, we would talk about overfitting in detail when we move on to the decision trees, because in decision trees the concept of overfitting is very important. So yeah, we would be talking about overfitting in a very short while. Then the next one is it is easily extended to multiple classes. Now this forces me to talk about the types of logistic regression. Guys, when we talk about logistic regression on a very generic level, there is only one type, that is logistic regression, or simple and multiple. But we have the first one, which is binary, wherein the answer is only 0 or 1. We have the second variant as well, which is multilinear. Multilinear function. Here, it can be multiple, and this is generally used when you have more than one case. For example, cars, trucks, and bikes. Right. So here it's not just 0 and 1, it's 0, 1, and 2. So this is the case where you might want to use logistic regression as well. So yeah, it can easily extend to multiple classes also. And then it has natural probabilistic view of classes. Okay. Then we have a disadvantage, that is it has a linear decision boundary. Now, why is this? I would really appreciate if you could, pause the video, give an answer to yourself, and then cross check. Now, why is this? This is because of the fact that logistic regression is derived from linear regression. And we know that. And this again goes back to forming a sigmoid function. And then it gets converted into a logit loss function, and then we have the output in the form of a 0 or 1. This is the math behind how linear gets converted into sigmoid, then into logit, and then the logistic function wherein we have a output. Right, guys? So that is how we work. Now, when we talk about this, again another very small difference that I would want to talk about, linear and logistic. In linear, okay, let me just come up with a small graph. Now in linear, there is no assumption that your value has to be within 0, and so if this is 1 and this is 0, and assuming this to be linear regression, there is no steadfast rule that this line of yours has to be within 0 and 1. But when we are talking about logistic regression, if this is like if the point below is your 0, and if we have another line on the top, this line which we are talking about, okay, this line which we're talking about, let this be a dotted line wherein we understand that this is the upper threshold, right? Now, if this is how it is, then logistic regression has to ensure that your data lies within 0 to 1. So this is where linear and logistic basically differ from each other, right? And here, because this happens to be a predicted value, it has to be between 0 and 1. So there is a range that is predefined for logistic regression. Right, guys? So I hope now it makes sense. Now we can call a logistic regression a linear regression model also, but it only varies in this fact that it uses this cost function which is called sigmoid curve. Sigmoid curve, sigmoid function or sigmoid curve, aka which is also known as uh, cost function. This is a very famous and a very frequent interview question, guys, and you might definitely want to lay stress on this before you go to your interview or before you appear for something as well. Now, when we talk about the hypothesis of logistic regression, here it generally tends to limit the cost function between 0 and 1, and that's how it works. Therefore, linear functions, they fail to represent this. And because they fail to represent this, I mean, it is not possible linearly to restrict the values between 0 and 1. That is why we use sigmoid function. Right, guys? Now, sigmoid function has a formula associated with it, and that formula is f of x, or f of n, p, whatever, a variable is equal to 1 by 1 plus e raised to minus x. Now here, guys, this is the formula of sigmoid function. All right, guys. So yeah, now going forward, now that we have understood what is the formula and how do we work on it, this formula has a derivation. Now there is a huge chunk of hypothesis that comes up into this, wherein here this equation is actually represented by 1 by it's 1 by 1 plus e minus, and then we would be having the linear regression, which is b naught plus b1x. This is exactly what we replace it with. So guys, you just have to understand that this linear regression which is used here is converted using exponential and this cost function in order to ensure that the probability score is returned between 0 and 1. Right? Now, how do we split the value to be 0 or 1 is the next biggest question. Like, if the value is 0.5, then what? Or if the value is 0.45, then what? Now, that is something that we have to decide, because not every time when the value is between 0 and 1, only 0.5 has to be a threshold. That is a very big flaw, or that is something that we are not supposed to decide. That is something that we are supposed to be informed by the person who is looking for logistic regression. Because let us assume that if you are working for a telecom sector, here 0.5 might be a threshold value. But if you are working for a hospital sector, right, anything beyond 0.2 can also be considered as one only. Like, again, taking the example of benign and malignant, here, if I say that I have up within 0.2 only, it is benign. Anything beyond 0.2 is malignant. Now, if I have case beyond or equal to, so here if it is even 0.2, then it's malignant. As simple as that. So guys, this is how we work on threshold limit, and this is how the decision boundary works, or this is how the values are split and adjusted between 0 and 1. Right, guys? So I hope we now have an understanding about what logistic regression is, and how do we work on logistic regression, and what is the principle behind working off a logistic regression, where do we use logistic regression, and the math behind it. Right? Now, talking a bit about cost function, now that we've discussed a whole depth of what logistic is, cost function is generally used in linear regression.
right? And this cost function, it represents the optimization objective. And the goal of this is to minimize the error so that we can have a model which is as accurate as possible. Right, guys? Now, if we try to use this cost function of linear regression in logistic regression, then it will be of no use because all that we are doing is trying to duplicate it. And here we need classification, while there it is regression, so it wouldn't serve any purpose. In this case, it would be very difficult for us to minimize the cost value and find the global minimum for the whole data set. That is the reason why we would be using functions like these for ease of calculation and for better performance of the system. Now, there is another very big question that is directly associated with this. That is, how do we reduce the cost value? And can we do it? Well, this can be done by using another procedure called as gradient descent. And the main goal of gradient descent is to minimize the cost value in itself. Right, guys? Now, gradient descent has an analogy in which we have to imagine ourselves. Let us just consider this small example wherein you're standing on the top of some building and there is something at the bottom. Now, in this case, we see that there are different parameters like
This is mostly a 2D kind of a 3D kind of a projection, but let us just understand. Now, considering this to be the case, if you would want to understand what is the path from here to here, just imagine these to be some terrains or mountains or whatever. Now, in cases like these, we might want to use gradient descent, but gradient descent is not the agenda for now. So let us just leave that topic for later. Right. Now, when you're using logistic regression, even this model does not go away without any assumptions. The most important assumptions behind logistic regression are, firstly, the outcome is to be binary. That is, it should have a yes or a no or a positive or we all know what is binary, right? It should be having two values. Then there should be no influential values. Now, when we say influential, we indirectly mean correlation, right? And the dependence should be very low between each other. And third one is there is no high intercorrelation. Okay, so these are the three assumptions that we have while we are working with logistic regression. Right, guys. Now, also talking about the threshold, let us just take a look at it. Right. Here, let us assume this is 5. Now, anything beyond this, if is dangerous, then guys, even in that case, this value would still be respected, and this value would, anything that we have here would still be considered as, anything below this would be considered as 0, and above this would be considered as 1. Or you can say anything below this is benign from the example which we were discussing, and anything above this is malignant. Right, guys? So that is an understanding about this. Okay, so now that we have understood this, let us go forward. Right, now this slide, it talks about the logistic function. Right, so here, logit function that you can see is simply the logarithm of odds. This is also called as odds ratio. Do not forget what odds ratio is, or do not forget the name. Odds ratio is this, okay? That is logit of x
is equal to log of x by 1 minus x. That is it. This is the formula, guys. Right? Now, when we talk about logistic function or logit function in specific, here the most important definition or the most important understanding is the value of logit function heads towards infinity. If you can see this at the top is heading towards infinity. I mean, it just keeps going and going. And as p approaches 1 towards negative infinity, it comes towards 0. Right? So this is an understanding of logit function. Right, guys? So here, as we can understand, the value of logit function heads towards infinity as p approaches 1, and it heads towards negative infinity as it approaches 0. Right, guys? So I hope that is understood, and this is an understanding about what logistic is, its advantages, its disadvantages, and its principle, and the formula, and some case studies that we have seen. Now that we have understood logistic, let me just remove everything on the screen. And let us now talk about decision trees. Now, this image which you see here is a small understanding about decision trees. Decision trees is as simple or as plain as it sounds. This is a tree, right? Now here, when I say this is a tree, we can see that this is the parent or this is the first node, followed by branches and followed by leaves. These are also called as terminal leaves. Right? So now, when we talk about decision trees, a decision tree can be used to visually and explicitly represent decision and decision making. Now, when we talk about a decision tree, it is moreover to come up with a classical understanding about the end conclusion, which can be a variable, or which can be a string, or which can be a number. Now, decision tree does not have a disadvantage like logistic, wherein the boundary is only between 0 and 1. Right? Decision trees are used when you have a lot of answers. For example, let me consider a very small example here, wherein the professional trade is being taken into consideration, and this is again taken for male and female. Now here we can see that if we consider this professional trade or professional job, or whatever the professional male female ratio that we're working somewhere at around 1950 to 1960, then we would see that for females there were very less number of trees that could come up with, and that too mostly into admin or teaching, or jobs which involved soft skills, or jobs which involved talking was moreover preferred by women, at least in somewhere at around 1950s and 60s. And when we talk about men, they were mostly into all physical forms of working, like right from driving a bus or to the armed services. So if we talk about the same professional branch in 1950 to 1960 between male and female, we would notice that the male side would have many branches and sub branches as well.
but then the female stream might not be so equally strong when we talk about 1950s or 1960s. But now, if I again come up with the same kind of a branch for male and female, I really wouldn't mind copy pasting this on this side. And now, whenever we look at this kind of a decision tree, this is called as a biased decision tree, wherein we see that the inclination or the weight is very heavily towards one side, and or wherein the domination is very heavily inclined towards one side and is weaker towards the other. Now, in these kind of biased trees, we would be using the concept of pruning. Right? Now, guys, what is pruning? Pruning is a word that is very like typically related to gardening. Now, also, if you look at the topic, which is decision trees, most of the names here they sound a bit biology-ish, wherein you have trees and forests and leaves and branches and pruning. So yeah, there's a whole lot of gardening that happens here. Now, whenever we talk about decision tree, if we see that there is a bias that's happening, that is when pruning comes into picture. Now, what is pruning? Pruning is, like in very general English, pruning is cutting a branch off of a tree. It is, just bought or it is done to ensure that the tree is symmetric. Now, if this is the kind of tree that I have, right, it is good. But if the same tree is, having a lot of pop out branches, which spoil the beauty of the tree, in that case, I would, just cut them off and, probably rip some leaves off to ensure that it is again looking neat and tidy or probably symmetric. That exactly is the aim or is the goal of decision trees. Right, guys? So now I hope you have understood what decision tree is and how we work on them or why do we need them. Now let us go into understanding. Now it is go into understanding the technical terminology that is associated with decision tree or the technical definition of decision tree. In decision analysis or in decision tree, a tree can be used to visually and explicitly represent decisions and decision making. Right? Now, like as the name suggests, these are used to come up with decisions on a much effective way. Like here, I would be now knowing that this percent of population is dead and this percent of population is survived. As simple as that. So now, based on this, I can take a decision. Like I would want to come up with a relief package or whatever. Right, guys? So this is the principle behind decision tree. Also, when we talk about decision tree, here decision tree is drawn upside down. Like we see that a normal tree goes like this. There is no tree which comes like this, right? But a decision tree, a virtual tree, it extends exactly the other way around, right? So here we would be noticing that the beginning point would be very small, and as we keep elaborating, we would notice that the tree would only keep further exploring into more and more trees to make it more complicated and to make it more uh, difficult for us, right? So this is what we do in a decision tree. Now, going further, now that we know that it is drawn upside down with its root at the top, now this is the root, right? The root. And in the image on the left, okay, this is the right. In the image on the right, we see that this part happens to be the root. Okay, let us just compare values, guys. This happens to be the root, all right. And then we have these, which are called as branches. Correct. Now that we have identified root and branches, the next part obviously has to be the leaf. Now again, when we talk about the leaf, it is two kinds of leaves. We have terminal leaf and we have just the leaf, right? So these are the two kinds of leaves that we notice in decision trees, right? And then we have root, which is also called as the root node. Guys, there are also AKA terminologies associated wherein they are interchangeably or interchangeably called as these or those also. Okay. Now this phenomenon which you see here, that is the split which is happening between like anything greater than 9.5 and less than 9.5, this is called splitting, right? This phenomenon, this is called as splitting. So these are some very important terminologies which we should know about when we are working on decision trees. Now, going into the next part of it, oops, I think we should take this a bit to the top. Let me just back this a bit. Right, now here we have a single decision tree, right? Now, when we talk about a single decision tree, here you notice that you have probably, okay, let me just start writing things again. So this is the root, this is your tree one, or this is your branch one rather. I mean, this is the whole tree, right? So this is the whole tree, this is the root, this is the branch one, this is branch 2. Now this is node 1, node 2, which is further again being split into different nodes. Right, guys? So this is the difference between a decision tree. Now let's talk about random forest also to understand the difference. Well, I think I was a bit fast here. So now, when we talk about a random forest, you can see the random forest is nothing but multiple decision trees. This is how at least I would want to define decision trees or the difference between decision tree and the random forest. According to me, n decision trees, sorry, I would say n decision trees make random forest. Now, how many do we have here? 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have 10. So there are 10 decision trees which are together making this as random forest. Right, guys? So yeah, now when we talk about the random forest here, what are the advantages or what are the disadvantages of decision trees in the first place becomes very important for us to understand the necessity of facilitation of a random forest. So now what we'll do is let us talk a bit about the advantages of decision tree and disadvantages of a decision tree, and then let's move into random forest. So here I have my advantages and then my disadvantages. Now, the first advantage is decision trees are very easy to understand. Like, this is the first point that I would want to say, and I also wouldn't mind saying that decision trees are, or rather decision trees have the most beautiful and the most interactive and the most understandable kind of an output, right? So yeah, the first point is decision trees are very easy. The second one is decision trees perform classification without a lot of computational cost, right? Now, I hope we all know that both decision trees and random forest, they both work on classification
and regression as well. Right? Now, talking about the advantages, now that we know the first one is it's very easy or it's very easy to understand. The second point is we would perform classification. We will perform classification without, heavy computation cost. Without heavy computation. The third one that we would be talking about in decision trees is they are capable of handling both continuous and categorical, that is number and categorical. The next one is they provide a clear indication of the output, right? Now, when I say clear indication, it is, I mean, the prediction, right? The prediction is very clearly understood, like which fields are important and which are not, right? So these are the, oops, right? So these happen to be the advantages of decision trees. Now, talking about the disadvantages of decision trees. Again, as I said, there is no model which goes without disadvantages. Okay, so the first disadvantage, the first and the foremost is they are less appropriate for estimation tasks. Okay, which means that here, if you would want to predict on a generic footnote, then it's great. But if there is something that is very keen and you are looking for something which is very, the approximation is very high, in that case, you wouldn't want to use a decision tree. So you would be having high approximation issues. Okay. And the second one that I would want to talk about is this is prone to errors. Sorry, prone. It's prone to a lot of errors. Now, what do we mean by errors here and can't we solve them? That is, whenever you're using a classification model with many classes and small training set, we would definitely have an issue. Okay, so that is the second part. Now, the third part is they can, okay, the third thing that we have to talk about is they are expensive. Okay, now what do I mean by expensive? Here, as the decision, I mean, if you're using the concept of pruning, wherein you're removing a lot of trees, then things may differ. But the process of growing a decision tree is computationally expensive. Okay, at each node, each candidate splitting the field, must be found. Like we have to identify which of the split is the best and where it should happen. Right? So that is the most important thing. Now that we have understood what is the advantage and what is the disadvantage, we also need to know that in order to overcome these disadvantages only, we have some pruning algorithms also. Okay, now what do these pruning algorithms? We have pre-pruning techniques and post-pruning techniques as well. Right, guys? So that is the important part here. Now, going further, when we talk about how to create a decision tree, well, there are many ways we could, there are n number of deciding factors. There are many ways to create a decision tree. That is not a problem, right? Like you can use this for many examples. Like here, you can assume that male again, female, and different kinds of jobs. Okay, so here this is the larger set of the same decision tree represented with many other classes and probably at an entirely different level. Okay, so that is how and that is where decision trees can be
used. All right, guys. And what are the three terms associated? Just to again let you know, we have root node, we have internal node, and we have leaf node. And the end leaf is called as terminal leaf or terminal node. Like wherever you find the word terminal associated, please understand that your decision tree will terminate in one step above. Sorry, in one step below or in one step further. Right? So this is a very brief understanding about a decision tree. Now, when we talk about a decision tree, there is also something which is called as the greedy approach. Okay, now what is this greedy approach? Now, greedy approach is basically based on a concept of heuristic problem thinking. Well, let me just write it down. It is called as greedy approach. And this greedy approach is based on heuristic problem solving capacity, right? Wherein we make optimal local choices at each node, at every node. Okay. And this algorithm can be summarized at each stage, like at a node wherein you can pick out some features you want, you can test them as a condition, and then you can again split the node into possible outcomes. So yeah, the way we work on this is really amazing. Now, when we talk about now that we've come this far, the next two very important terminologies associated with them are the first one being entropy, the second one being information gain. Right? Now, these are the two words which are very important. Now, when we talk about entropy here stands, okay, let me just write down entropy E is equal to, or entropy is equal to how homogeneous is your data, that is the homogeneity of your data. Now, if the data is completely homogeneous, let me just write down. Now, if you feel that it is completely homogeneous, then it is 0. If you feel that it is not, then it is 1. That is what we should understand between the difference of, if it is homogeneous and if it is non-homogeneous. Now, let us talk about the second part of it, which is information gain. Now, information gain talks about the increase or the decrease or probably the variation. I mean, both of them are the same. Variation in entropy. Okay, so here information gain looks into that. Now, again, information gain has a value associated, while entropy, it mostly stands between 0 and 1. Now, if the entropy is 0, then it means that your data is completely homogeneous, that is, it is super homogeneous. Okay, but if it is 1, then it means that your data is 50-50 divided. So these are the kind of conclusions that we can draw when we are working on decision tree with respect to entropy. We have understood what is information gain also. And an attribute should have, okay, now this again is a very important point when you are appearing for an interview. This question should definitely be asked if you come across this topic of information, as if you come across this topic of decision tree or random forest. Now here, when I talk about entropy and information gain, an attribute or your output should always have a very high information gain to be selected for splitting. And when you talk about entropy, it should, vary. Now, if this is high, then obviously entropy is meant to be low. Right, guys? So, yeah, now based on the computed value of entropy and information gain, we choose which is the best attribute for the next particular split or next particular step. So, if you ever have a query that is how and where and what we can use
entropy or information gain for, now you have an answer. And now I'm pretty sure you could also justify where, why, and how it can be used. Right? So yeah, now let's go further into random forest and let us understand what random forest is. Just clear the screen, change the cursor, and right now we will go to the right. So I think the slides arrangement has shuffled a bit, but then that's still fine. Now, when we talk about a random forest is a classification algorithm, guys. Now, we have just seen what random forest is, and also just to again write things here, decision tree is equal to n decision trees is equal to a random forest. So now that we have this point in mind, let us go forward and understand what random forest is. Now, we know random forest is a classification algorithm which consists of many decision trees. Right? Now, what is the use of random forest tree here? Random forest tree, it builds multiple decision trees and it merges to get an accurate stable connection. Okay, when we talk about what is the use of random forest, you can see here that is the definition itself. It builds multiple decision trees to merge and get an accurate, I would say a bit more accurate and probably a bit more stable connection as compared to decision tree. Now that is something I would definitely like to state. Now talking about the assumptions of random forest, at each and every step of building level or at each and every step of a random forest, your algorithm would in itself identify the best criterion of where to split. Right, guys? Now, when we talk about a random forest, while building a tree, we use not the whole data set, guys. That is very, very important here. We use only a bootstrap sample. The whole chunk is not taken into consideration. Right now, that is very important thing which is to be understood about a random forest. Now, when we talk about now, there is again a very big query that is asked or that is very famous when we discuss the concept of random forest and decision trees, and that query is random forest is n decision trees, correct? In that case, why does random forest become difficult for us to understand? Now, guys, when I said the example or the image which we saw, it has only 10 decision trees, which is still easy to probably visualize on one screen. But what if the count increases to 100 or probably 500 decision trees within one random forest? Then it is no longer easier to visualize. We would need a probably a mega TV or a mega screen to look at each of that. And that is the reason why random forest and decision trees do not have the same kind of output, or they do not leverage the same kind of visual comfort with regards to understanding the output. So, and therefore, that becomes a challenge with regards to random forest, right? So yeah, now talking about random forest, there are two types of randomness that are built into trees. The first, wherein each tree is built on an entire random sample from the original data, or the second, wherein each tree node or within each tree node, a subset of features are randomly selected to generate the best fit. Now, both of them are a bit different, and again, both of them are used or both of them keep happening as a process of execution of the algorithm of random forest. Now, when we want to interpret a random forest, here we have different values like importance score, which measures the contribution of each feature. right? Now, let us assume that you have 10 features in your data set or within your random forest, right? So I have 10 features, A, B, C, D, E, F, G, right? Now, within these 10, okay, let's assume there are 10 features. Now, within these 10 features, if this has 70, this has 40, this has 80, this may have 20. But guys, please understand that all of these would come up to 100, right? All of these would come up to 100. Okay. Now, this becomes very important for us to understand. And what is this? This is the process of uh, selective feature importance, wherein you would understand which of these are very important and you will eliminate the ones which are not important, thereby making your forest or making your random forest more and more neater, cleaner, and accurate. Right? So these are some very important steps. Now, when we talk about partial dependency plot, this is also something very important. But here, the important score of features does not tell how a feature and a class are correlated. Correct? So the partial dependency plot can visualize marginal effect. So this becomes important. Now, when a feature is correlated to the class, the plot looks like the left figure, I'll just draw a figure here so that we understand. I mean, these are very highly occurring probabilities that we have, right? So here you see now this is how it can get split. And what is this? This is partial dependency. Okay, now here in partial dependency, we would just try to understand how one is dependent on another, or how is like the most important takeaway here is partial dependencies can be misleading. Okay, and we would know if how is one class related to another, if they're related or not, right, guys? So this is the most important thing here. Now, when you are working with decision trees, sorry, random forest, the other biggest problem is they get biased towards features with more categories. This is a generic this is a generic inbuilt problem within random forest, right? So that is why we use this. Okay. Now going forward, understanding about a bit more about random forest. Random forest is again, very solid, or it is very robust towards outliers. When we're using out, like, let us assume that your data set has some outliers which you are feeding into random set. So clustering with random forest, it can avoid the need of feature transformation itself. That is, some other random forest functions can also be used here. For example, probability or interpretation. We can use a lot of methods here. Okay. We can also try clustering with random forest. So guys, when we talk about random forest, there is literally a lot we can do. But in short, if you would want to understand what is a random forest, then I would say random forest is nothing but uh, calculation of multiple decision trees, wherein you would have a very huge data set, wherein you would be having solid packed data and all, right? But here, when you talk about uh, understanding random forest, here the next word we have is Gini index, or Gini impurity index. Okay. Now, when we talk about Gini impurity, it is used to calculate a value called Gini gain for any split, and a better split has higher Gini index, right? So higher the Gini value or Gini gain, I would say better or much accurate is your result. Right, guys? So this is an understanding about random forest. Now that we have understood what is a
logistic regression, and that we have understood what is a random forest and a decision tree. Also, let us now take a look at the hands-on of logistic regression, right? And guys, before we move into it, there is one very important point that we needed to discuss about random forest, and that is why is random forest more accurate than decision trees? Because random forest leverages the aggregate of the whole tree outputs by averaging the values, and not like how decision tree works. Okay, so this is what we do in random forest, right? So yeah, now what we'll do is let us head on towards the logistic regression hands-on part, right? So let us go into it. Let me clean the screen as well before we do that. Done that. Right, so here we are, and here I have my logistic regression which we are using. Right, so guys, as you can see, I'm using a Titanic data set, and this Titanic data set is huge. Okay, this Titanic data set is something which is very famous and very popular. I mean, you just have to go into the Google and type in titanic.csv, and you should be having access to this. Now let us just note what are the libraries that we're using here. I'm using pandas, numpy, seaborn, matplotlib, and my math. Okay, now as we keep going into it, this is the data set. Now what kind of a data set we have? We notice that this data set that we have here, the first one is categorical. This is categorical. This is a string. This is categorical. This is continuous. Okay. This is categorical. This is categorical, and this is continuous. So this is a string. So the rest all are categorical. And I would really not require a lot of columns here. So we would remove the unnecessary columns as we keep going forward. But let me now just scroll down and let us go to the second step. So here now you can see we have head of 10, and because of this command I would be having my top 10 commands, or sorry, top 10 rows of my data set. And we know that within Python it starts from 0. So if you say 10, you would be having 0 to 9. Now going forward, I think that was a bit. Right. So now we are moving on into the data visualization part. Let me just quickly, skim you through the data visualization concepts also, because at the end, you would realize how every project that you work on, it could be linear, it could be logistic, or it could be any problem or a project that you work on would involve a lot of data cleaning, data visualization, data manipulation, and then you would notice that at the end there's only 3 lines of or 4 lines of the code which is doing it all. Now, all the while we are trying to prepare this data set for the final operation, right? So here I'm using a small plot to check for my survived and the sexes we have. So we have male and female, and we see that we have so many male who have survived, and so we know that 0 is not survived and 1 is survived. So we see that so many male have lost their lives, and only very few male have gained their lives. But again, a lot of women have been able to save their lives, guys. So see, I hope you are able to notice the gender discrimination here as well. Okay, and this is an understanding about how we work on simple plot, and this is here a count plot. Count plot is an extended version, or is a high level version of a histogram. Right, now going forward, The next one we have is a Titanic data set, wherein I'm using a histogram to plot my fare. And here I can realize that most of the people who are here in here, they have only, I mean, most of the people who are traveling, they are within a range of, $150. That is something that I would conclude. Going forward, I'm checking the info. Now, guys, this is what we were discussing about in one of the previous sessions. When we have non-null objects, it means that I totally have 887 entries and there are no null objects. So all of them are full. So we don't have to get worried about NA values or removing NA values or substituting them. That is not something that we have to get worried about right now. Right now, there is this plot here, which is a heat map or which is a count plot, and this is a count plot of age against the frequency. So I see that most of the people who are traveling are within 25 to 40 range. I mean, that's the highest people. Okay. Now again, okay, they're not 25 to 30 years of age, guys. So this is the age here, and I think this age is also 25 to 30. Okay, now going forward, the next one we have is I would want to check the null values, and we know how to check null values. This is something that we have covered in the previous sessions. We would use is.null followed by the empty brackets, which would give me a list of all the null values associated, and we have not even a single true and all to be false here because there are no NA values or there are literally no missing values, right? Now, oops, yeah. Now taking this a bit more forward, the next one that we have is to check the sum of null values. And how would I do that? In order to do that, the only thing I would add is dot sum. And we see that there's no null values, so not to worry. Now I'm using a box plot, and guys, now I hope you know that when we use a box plot, what is what. So here you can see that this is an outlier that we have. All these are outliers, right? This is my lower extent, this is my upper extent, these are my whiskers, right? This is my mean, this is how my data is distributed or where my maximum data is distributed, right? And then what else do we have here? We see that this probably is a bit skewed. Again, what is skew? When it is inclined either towards the right or the top or the bottom, that's when we call it a skew. I mean, I'm just naming all the different terminologies that we have involved here. Okay, now that it is understood, a box plot for the passenger class and the age, and I see that most of the people are traveling in first class, and I think there are very less people who are traveling in third class, which means that third class must be a bit more expensive. And also I note that people traveling in class 1 and 2 are older than class 3. So yeah, it gives a very complex understanding about what it is. Right, now let us go further, and this is now the head of top 5 values. And guys, because now we are able to see that the data is a bit more cleaner, what I would do is I would use a heat map to check if there are any null values or not. We're just using this again and again to come to have an understanding about what are the different kinds of values that we may come up with. Okay, and then from here comes the data manipulation part. So now that we have understood data exploration and we have worked on data visualization, now we are working on data manipulation. Right? So this is what we mean by it. So now going forward, when we talk about data manipulation, the first step or the first thing that I would be doing here is to change the value of my, so here what is the sex column marked as? It is currently marked as male and female. Now I would want to use some procedures and I would want to convert the sex column wherein male is 0 and female is 1. right? So this is what I'm trying to come up with. And in order to do that, I am using, right, okay. Well, that was my mouse getting slipped, guys. Right, so here you can see we after the heat map, right. Now I'm using get dummies. Now get dummies is a very important functionality within pandas, and get dummies converts binary values or binary variables into numbers. That is the job of get dummies. Now I'm using get dummies to convert male and female into 0 and 1. And now we see that I have male and female. Now guys, female is a call. Initially, this is how it was supposed to be. Let me just, right. So this is how it was supposed to be. 0, 1, 1, uh, 1 and 0. But then we have removed this column, and how did we do that? We did that using drop first equal to true. And guys, why did we have to do that? Because even if we remove this column, this one column is still able to retain the information if the gender is a male or female. So we wouldn't want to overpopulate the whole data set, or you wouldn't want to overpopulate your machine learning algorithm with a lot of data which is required and unrequired as well, which is the reason why we would be dropping the first column. Same here. When we talk about the second line, I'm using P class, which is passenger class, and within passenger class, we all know that we have three passenger classes, first, second, and third. So this is also what we see. But then guys, even if the first column is removed, second and third would still retain the information. How is that? If we have zeros here, then it is understood that the other one is 1. If we have 0 and 1 here, then it is understood that the other one is 0. So if we have two numbers out of 3, then it's not very difficult for us to predict or understand what is the leftover number, right? So that is exactly what we are trying to do in these conversions here, and these conversions are getting achieved with the use of get dummies, and then we're using pd.concat, which is concatenate. And now I'm sure we all know what concatenate is, now that we worked on data exploration and data visualization and data manipulation together, guys. Concatenate is, it's because of that feature I have these 3 here. But now that I have these, I would definitely want to remove my sex. I would also want to remove my P class, that is passenger class. And name, because it's not required, I would want to remove this too. And that is what I'm doing in my step below. As you can see, I am removing my sex, I'm removing my passenger class, and I'm removing my name. And in all these places, I'm taking my axis is equal to 1, or that is I'm basically using in place is equal to true here. Right, guys, let us now drop a column to print a data set is what is written. Now let us just go ahead and check. I'm again using Titanic data of head is 5, and you can see now I do not have the name, and also my male column is changed, and also passenger class is removed. So all of them are well and good, right? So now that we have understood what to do and how to do here, let us go on into the actual part of it, that is the crux of data science or machine learning. So here I would now be considering survived column on my y. Okay, let me just use the pen. Right, so here I would be considering survived, which is my dependent, and all other columns as independent, right? And how would we do that? In order to do that, what I would be doing here is I would now be using sklearn.model selection. And okay, even before that, I'm dropping. So if I'm considering Titanic underscore data, which has all my data, and I'm dropping survived, it means that X has all other independent variables and Y has only one, which is survived. Right now, I would be using the test train split, which is sklearn.model selection, and within this I would be using the split. Now we all know what split is used for. Split is used to ensure that we have train and test set. Why? It is to ensure that we give our machine learning algorithm to the train model and then we check the performance of how it is working on the test model. Right? Now going forward, from sklearn linear model, I'm importing logistic regression. And now this logistic regression is being passed into log model. Okay, now this is just a variable, guys. This is not a function or neither a functionality. Please do not get confused. Now I'm using this log model and I'm fitting this to my train value. So now I hope you are able to understand what we are doing. Let me just scroll this a bit to the bottom. Right. So now let us understand what is it that I'm doing here. I'm considering, I'm passing this logistic regression into log model, and then I am fitting this into my train values, right? As you can see. And in my next step, now that this is done, I am using log model predict, and I'm trying to predict this on top of test. Right, guys? Please understand, I'm trying to predict this on top of test, and it means that I am now kind of checking how is it performing. Like how is my train model performing against the test, because test happens to be the actual or test happens to be the pure, while your train model would become your predicted, or your train model is impure because we have added machine learning algorithm into it, right? And in order to see how my train model is performing against my test model, I would be using something called an sklearn.matrix, within which we have a classification report. And this classification report would give me an understanding about how well or how good my model is performing. But then, because just a classification report would not give you a final understanding about what it is, I would also be using a confusion matrix. And what would confusion matrix do? Confusion matrix would give me the values between actual yes and actual no, while predicted yes and predicted no. Thereby, I can check my accuracy score. Now guys, here as you can see, I have an accuracy score of 74.9, which is okay, which is a decent score. Okay, but this can be improved. Okay, and how can this be improved? By changing the features which we've taken on the top, or probably removing unnecessary features, or adding unnecessary or sorry, by removing unnecessary features, or by probably changing values. So this is, or probably you see the threshold. There are a lot of ways that we can still work on using logistic regression, right, guys? Now what does 74.9% here mean? It means that my train is performing this percent accurate against test, which means that there is still scope of almost up to 26%, which can be improved, or 25.1%, which can be improved. And this is huge, because generally in data science we would prefer anything which is above 90, and this is almost 15 below that. So guys, yeah, I wouldn't call this model a useless model or a model which would not suffice any requirement, but I hope the more important part here is that you have understood what is logistic regression and how do we work on logistic regression, what is decision trees, what is random forest, and how do we work on them, right? So guys, this is an understanding about it. So now I hope you have understood what are the different types of classifiers we have, where, how, and why we use them. Okay. And also, notwithstanding that, how would the use of each of these, or how has the defect of one model become the requirement of another model, or how has the requirement of one model become the necessity, the facilitation for another model. Okay, the advantages and disadvantages associated with them, and also a complete hands-on demonstration of logistic regression, including the evaluation metrics. Right. So I really hope you have enjoyed how do we work on them, and also I hope you enjoyed learning the difference between each of these. So guys, I would really like to appreciate each and every one of you for your patience and for your understanding. Thank you very much for your time. And if in case you found this video to be useful, then guys, please do not forget to hit the like button, because when you do that, it would encourage us to make more videos. And also when you hit the subscribe button, it would let us it would let you have regular notifications about whenever we come up with a video. And please do not forget to hit the bell icon too, because that is the one which will give you notifications. Thanks again. This is me, Varun, your trainer, your mentor, signing off, wishing you all the best for your future endeavors. Have a great day.